Our question here is a fraction. We have 7a over the fifth root of 4a to the 7th b to the 13th. And we are tasked with rationalizing the denominator. So here we go. The first thing we can do is simplify the denominator. Because we have a to the 7th, the fifth root of a to the 7th, and the fifth root of b to the 13th, we can do a little bit of simplification here. So let's go ahead and keep 7a in our numerator. We have the fifth root still in our denominator for now. We can't do anything. There's no fifth root of 4, so we're just going to leave him there. The fifth root of a to the 7th is a outside of the radical, and we have an a squared remaining on underneath the radical. The fifth root of b to the 13th leaves us with b squared on the outside of the radical and b cubed as a remainder under the radical. Alright, so now our goal is to multiply, because we have to get rid of the radical. That's how we rationalize the denominator. We have to multiply the radical by something to be determined, that we'll determine, in order to get rid of the radical. So what we're doing is looking to make a perfect fifth square. And when we do that, everything will be able to come out from underneath the radical. So once again, we have our ab squared there. We're going to multiply this denominator by the fifth root of something in order to make everything fifth. So we know that 2 squared is 4, but we need to get a total of 2 to the 5th in order for the number to come out from underneath the radical. So if we have 2 squared and we need to make it 2 to the 5th, we want to multiply by 2 to the 3rd. If we have a squared and we need to make it a to the 5th, we need to multiply that by a cubed. Now remember that we do that because whenever we're multiplying exponents, we always add the two numbers together. So a squared multiplied by a to the 3rd is going to give us a to the 5th. Now we have b cubed, so we're going to need to multiply that by b squared, and that's going to give us b to the 5th. So right now, I'm just going to go ahead and do this multiplication so we can get a clear vision of what we're doing here. We still have our ab squared. Now we can take the two radicals underneath the radicals and multiply them together under one radical. So we still have the fifth root. 2 squared plus 2 cubed is 2 to the 5th. And a squared times a cubed is a to the 5th. And b cubed times b squared is b to the 5th. So I hope you're seeing a pattern here. I'm going to go ahead now and pause on the denominator and work a little bit on the numerator. Remember that whatever we do to the denominator, we must also always do to the numerator. So we have to multiply the fifth root of 2 cubed, a cubed, b squared, also in the numerator. Now 2 cubed is 8, and then we have a cubed and b squared. Alright, and when we multiply those guys together, we're going to have 7a fifth root of 8a cubed b squared. Okay, so this is now what we're looking at. I'm going to move down here to this line, and we're going to continue to do some rationalizing of the denominator. So the numerator stays the same. I'm going to go ahead and rewrite that. 8a cubed b squared. Over that we have a b squared. Now this is where the fun comes in. The fifth root of 2 to the fifth is 2. The fifth root of a to the fifth is a. And the fifth root of b to the fifth is b. So by multiplying the missing pieces, which we've determined as the fifth root of 2 cubed, a cubed, and b squared, we now are able to get the radical out. Okay. Still some more simplifying to do and some more combining of like terms. So we have 7a fifth root, 8a cubed b squared. That stays the same in our numerator. Now we're just going to combine like terms. It's not really combining even. All of these terms that we have in our denominator right now, we're multiplying those together. So let's just do that. We'll go ahead and start with our coefficient, which is 2, and then a times a is a squared, and b squared times b is b cubed. We're almost done here. One last thing we want to take care of is, are there any common terms in the numerator and the denominator that we can use to simplify? And, in fact, there are. We have an a here, and an a in the numerator, and an a squared in the denominator. So we can go ahead and simplify that, which then leaves us with 7 fifth root of 8a cubed b squared in the numerator, and 2ab cubed in the denominator, because that a and the a in the numerator and one of the a's in the denominator we're able to simplify. This is our final answer. 7 fifth root of 8a cubed b squared over 2ab cubed.